So first, on our chapter review, we're going to look at this function, and we have to determine, well, which one of these is a period of the function. Now, in a trig function, the period, like let's say we had the sine of b, say, times x. The period would be 2 pi divided really by the absolute value of b. You can't have a negative period. So in this situation, our period is a fraction because b would be 1/4 because you're dividing by 4. So our period would be 2 pi divided by 1/4. Well, if I'm taking that fraction, we have 2/1 really here divided by 1/4. If you just switch that to multiplying, so 2/1 times the reciprocal of 1/4, so times 4/1, and this would be 2 pi over 1. That would become 8 pi over 1, or just 8 pi. So our period here is 8 pi. So on here, we have to look at the height of a function of a water of a beach is given by this trig function, where t is the hours after midnight. Which one is correct? Select all that apply. The difference between the highest and lowest water levels is 12 feet. Well, if I look here, I know that the amplitude, or the height of the wave, is 6 feet. So from the highest point to the lowest point, we're going to go up 6 feet, and then to the lowest point, we're going to go down 6 feet. So the difference between them is going to be a total of the 6 plus 6, which is 12. So this is true. Now the difference between the highest and lowest being 24, well, that's not true. We already showed it's 12. Now here, the water level is at its highest value, 1.5 hours after midnight, at midnight, or 3 hours after midnight. So what I'm going to do is just graph that. So on here, with this calculator, you just type y equals, and you put 6 times the sine of, and I'm going to put 2 pi divided by 12. And then this shouldn't say equals. This should say plus negative pi over 4, or just minus pi over 4. And I have to put in an x here. So let me just hit second insert and then put in an x. So now what I'm going to do is graph that function. If you notice, I have a bad viewing window, so I'm going to press zoom 6. And we have to figure out, well, where is that point? So I'm just going to trace this. And see how many hours after midnight that is. It looks to be about 6 hours after midnight. So none of these are true. So A is the only one that's true. Now here are graphs of 4 trig functions. Which one has an amplitude of 5 and a midline at 3? So let's find the midline at 3. So here I would just go up 3, 1, 2, 3. Draw in the midline. And then find where is my amplitude, or the height of the wave. So from the midline, it goes up 1, 2, 3, 4, 5. So here, this has an amplitude of 5. And my midline is y equals 3. So my choice here is A. So now in looking at this function, we have to find the midline and the amplitude. So first I notice the midline right here. So my midline is at y equals -1, -2, -3. And then my amplitude, we have to see, well, how high is the function? The function is too high, so the amplitude is 2. And then we have to figure out, well, what's the period of the function, or when does it go through a full cycle? So what I'm going to do is I notice here that my period, I can go from the top of this wave to the top of that wave. And if I think about shifting this, I could shift it kind of backwards, and I go from pi and then to pi. So if I take that part, its period is going to be pi. And then the next part of this would be to write an equation of the function. So to write an equation of this function, I noticed that it's going to kind of start over. If I thought of this graph and moved it back to the start here and thought that here it would start at like 2 and then look at the things that it would move it. I'm going to model this with the cosine function because it starts up here almost at 1. So first, my amplitude is 2. So I would go 2 times the cosine function of, we have a regular period of 2 pi. So we would just put of theta. And then I moved it pi over 2 units to the right. And then remember, to shift it to the right, I actually subtract that many units. So I would minus pi over 2. And then I moved it down 3 units. So then I moved it and I would subtract -3. So I'm going to label the parts here. This was for the amplitude of 2. This 1 theta, or just the regular theta, was because the period was normal. And this minus pi over 2 was because we moved pi over 2 right. And then this -3 was because we shifted the graph down 3. Also, I made a small mistake here in my period. The number of units that I go here is actually 2 pi. So I move, that part is moving a pi and then another pi. So my period here is 2 pi. And that's why we have the regular cosine of theta here and not any sort of number to multiply to make it smaller or to divide to make it bigger. So now for number 5, a carousel moves in a counterclockwise direction. So we're spinning this way. It makes 1 complete revolution in 16 seconds. Han is 11 feet from the center. So remember, that's going to give us an amplitude of 11. And we now need to make our trig function. Well, if you remember, our regular trig function would start here, and we're spinning it halfway around a circle because it's going counterclockwise. We moved it pi spots to the right. So in devising this, I'm going to go v is equal to our vertical position. So because we're doing vertical position, we're going to use the sine function. Now my amplitude needs to be 11. So I write 11 times the sine of, and since we're doing a time function, we would go 2 pi times the time, and then divide that by my revolution here, which is going to be 16. And then I move pi spots to the right. So I'm going to subtract pi, because that would move it pi spots to the right. So now to graph this, I put in our function 11 times the sine of 2 pi. We can't put in theta, so I put in x divided by 16, and then minus pi. So then I graph that. So if you notice, this function starts at 0, and it goes down to negative 11. So if I counted this, we're going to have a time period of 16 seconds. So I'm just going to write 4 seconds, 8, 12, 16. So I know that here, if I traced out this function, in 4 seconds, it hits its bottom point. So it's going to go 4 seconds. It's going to be at negative 11, about right there. And then at 8 seconds, the carousel goes back over to this point. So the distance is at 0. At 12 seconds, it's going to be up here, which is going to be positive 11. And then at 16 seconds, it goes back to 0. So the graph looks like that. So now we have to sketch a graph of 4 times the sine of theta minus pi. So what I'm going to do is let you do this with Desmos and just sketch which part of it is on there. So 4 times the sine of, and I'm going to put in x, and then minus pi, and then I'm going to graph that. So I noticed that the graph started at 0, and then the minus pi, remember the sine function, is going to be 4 times as long, so the period is going to be 1, 2, 3, 4 there. And if I trace this, we're at our lowest point here, looks to be at about negative 4, which would be negative 4, at pi over 2. So then at pi, we go back to 0. At 3 pi over 2, we're going to be at positive 4. And then at 2 pi right here, we would be back to 0. So there's a sketch of my function. Now we have to compare it to the function y equals the sine of theta. So in comparison, you can graph that. So if you just press the sine of x, this graph, the amplitude, is 4 times as big. And then secondly, the graph was shifted pi spots to the right. So I'm just going to put translated pi spots right. So now in this case, the hours of daylight in Glasgow, Scotland can be modeled by the function given 6.5 times the cosine of 2 pi d over 365. So what's our amplitude? So our amplitude here is 6.5. And what does that mean in terms of the hours of daylight? Well, we could say, between the highest and lowest hours of daylight would be double this. So we could say the difference between the highest and lowest. $13 from its highest point to its lowest point. So that's not at all times. Like the most daylight would be a reading, and the least reading would be 13 hours lower than that. Now, to find the period, so the period here is going to be 365. Mathematically, here's what's happening. So we do 2 pi divided by, remember, b. But in this case, b equals 2 pi over 365. So mathematically, this becomes 2 pi over 1 divided by 2 pi over 365, which, remember, when we're dividing two fractions like that, this turns into 2 pi over 1 times, and then we multiply by the inverse, which is 2 pi over 365. Our 2 pi's cancel out, and that gives us just 365. So that is 365 days until the daylight function resets. And then our midline is 11.36 hours here of daylight. And that would be the average amount of daylight.